What if the single decision you make, every oil change, quietly determines whether your engine quietly fades away around 150,000 miles, or sails past 300,000 miles with ease? Same vehicle, same power plant, same driver habits, same service schedule. The only thing that ever changed was one seemingly small detail: the viscosity grade of the oil most people barely pay attention to. And here's the twist that catches almost everyone off guard. The grade many shops and owners instinctively reach for as the safer, tougher option turned out not to be the champion in everyday reality. This isn't speculation pulled from message boards, brand advertisements, or gut feelings. The findings came straight from logged oil temperatures, tracked wear element trends, detailed used oil laboratory reports, and real mileage accumulated under strictly matched conditions. By the time the full comparison wrapped up, it became obvious which viscosity actually delivers superior long-term defense in the kind of driving the vast majority of American owners do day after day. You will also see how one choice can secretly drag down fuel efficiency and engine safety at the same time, without ever setting off an alarm or making the car feel any different. Stick around until the finish. The final verdict left even seasoned technicians scratching their heads in surprise. Why does this comparison actually carry real weight? The endless argument about 5W-30 versus 5W-40 refuses to die. One camp insists thicker oil gets more cushion, facts in longer life. The opposite camp says, follow what the factory wrote, thinner is designed for modern engines. Both groups usually overlook the decisive factor. Manufacturer approvals and lab ratings are created for idealized conditions, dyno runs, or worst-case abuse scenarios. Real engines don't live in test cells. They endure traffic jams, quick errands, blazing summers, long interstate stretches, and gradual mechanical aging. That's where viscosity choice quietly carves out engine destiny over decades. This wasn't a short laboratory simulation, a cold weather flow contest, or sponsored content. The evaluation ran on a contemporary, naturally aspirated gasoline engine operated in completely normal fashion across complete drain intervals. Fuel supply, driving routes, city, highway balance, oil filter, mileage between changes, everything stayed identical. The single controlled variable, the hot viscosity grade. Phase 1, high-quality full synthetic 5W-30. Phase 2, high-quality full synthetic 5W-40. No premature drains, no hand-picked results. Number 1. Why do people constantly mix these two grades up? At first glance, 5W-30 and 5W-40 appear almost interchangeable. Identical cold flow behavior, the 5W, both satisfy current industry and OEM specifications, and both carry approvals for a huge number of US and market engines. But once the engine reaches full operating temperature, their personalities diverge sharply. The 30 weight circulates with less drag, builds pressure quicker, and reduces pumping losses. The 40 weight lays down a visibly thicker barrier layer and often feels more robust during extended heavy use. The real debate isn't which one is inherently stronger. It's which one genuinely shields the engine better across thousands of ordinary trips. The most widespread misconception is simple: thicker must always equal better protection. Logically, it makes sense, until you realize engine component wear isn't uniform. True protection hinges on rapid oil delivery, stable temperature regulation, consistent hydraulic pressure, and prompt arrival at loaded surfaces. In certain situations, extra thickness helps. In others, it quietly works against you. That tension is exactly what this side-by-side test exposed. Number 2. What did we actually track, and why does it matter for engine survival? We focused on 4 objective, longevity-linked measurements: oil temperature patterns during real routes, viscosity retention across full drain cycles, wear element concentrations from independent lab analysis, overall engine response during typical mixed American driving, urban crawl, short errands, moderate highway runs. No it feels smoother impressions, no dyno bragging, only hard numbers. Differences started appearing within the first couple thousand miles, but the decisive patterns only crystallized when the driving truly mirrored average daily routines. Number 3. The surprising temperature behavior that changes everything. Under the exact same roads, speeds, ambient conditions, and load profiles, the oils produced noticeably different heat signatures. During steady, sustained highway running, the 5W-40 usually stayed a few degrees cooler. Yet in short-trip urban driving, stoplights, school runs, grocery errands, the 5W-40 consistently ran 5 to 10 degrees hotter. That small gap might sound trivial. Heat is the silent destroyer. Every extra degree speeds up oxidation, burns through additive packages faster, and accelerates viscosity breakdown. When short trips dominate, as they do for most US vehicles, oil rarely achieves a fully stabilized thermal plateau. Thicker grades take longer to flow completely, generate more parasitic friction early in the cycle, and start trapping heat sooner. That exact pattern showed up clearly with the 40 weight. Number 4. The hidden trade-off: fast delivery versus thick cushion. Every engine operates in this constant compromise. Quick oil flow gets vital lubrication to main bearings, cam lobes, timing chains, and cylinder walls during those critical first seconds and partial warm-ups. A robust film layer fights metal-to-metal contact under peak load. The 5W-40 definitely delivered a more substantial barrier once everything was scorching hot, especially during prolonged high-speed cruising. But in fragmented daily duty cycles filled with repeated cold-to-warm transitions, frequent stops, and short accelerations, that thicker oil rarely hit its optimal operating window. From behind the wheel, zero drama, no knocks, no CELs, no obvious complaints. That's the danger zone. Silent, cumulative stress that chips away at total lifespan without ever announcing itself. Number 5. What the used oil reports started revealing halfway through mid-interval samples told an interesting story. Neither oil looked dangerous. Both stayed within safe limits. But trends diverged. With 5W-30, where metals held steady, viscosity stayed tightly controlled. Oxidation numbers progressed slowly and predictably. With 5W-40, metals looked excellent on long highway legs, but fluctuated more during city-heavy periods. Oxidation ticked upward noticeably faster whenever short-trip operation dominated. This wasn't catastrophic breakdown, it was simply different real-world behavior. Number 6. Viscosity holding power. Which one stayed truer to spec longer? Lab numbers don't lie. The 5W-30 maintained its viscosity band almost perfectly from fresh to drain. Very little shear down, extremely linear behavior across every condition. The 5W-40 resisted shearing admirably when continuously hot and heavily loaded. But it displayed wider swings whenever the engine lived in mixed, stop-start reality. In short, the 40 weight excelled in ideal textbook scenarios. The 30 weight proved far more forgiving when life wasn't perfect, and life usually isn't perfect. Number 7. Wear metals, the ultimate scoreboard. Everyone wants this answer. The difference wasn't night and day dramatic, which is precisely why it's meaningful for real ownership. Steady-state highway runs, 5W-40 edged out slightly lower iron counts. Everyday patchwork driving, 5W-30 produced tighter, more repeatable low-wear numbers with far less sample-to-sample scatter. Veteran mechanics pay close attention to that second point. Catastrophic failures rarely come from one brutal overload. They arrive from thousands of tiny, inconsistent lubrication events stacking up over years. Number 8. The single word that decided the test: variability. That one factor separated the two oils more than anything else. The 5W-40's performance swung noticeably depending on warm-up duration, load level, and trip length. The 5W-30, almost dull in its consistency. It delivered nearly identical behavior, whether the engine was half-warm, fully hot, short hopping around town, or cruising for hours. Predictable oil. Lower risk over decades. Number 9. Why this gap grows wider as mileage climbs. At 30,000 miles, an oil that struggles during short warm-ups is only mildly annoying. At 150,000, 200,000 plus miles, those same characteristics become punishing. Clearances open slightly, heat soaks linger longer. Contaminants build faster. An oil that already shows instability early will amplify problems later. That's why many high-mileage specialists quietly shift viscosity strategy as engines mature. Number 10. The trap of more is always better. Here's what shocked many readers. The 5W-40 wasn't inferior, it was simply over-specialized. It shines for towing trailers, high-speed desert runs, extreme ambient heat, heavily worked turbos, or any situation where oil lives at elevated temperatures for hours. For ordinary commuting, school drop-offs, weekend errands, and average mixed use, the extra film thickness delivered diminishing returns while introducing measurable downsides: higher heat in short cycles, wider variability, subtle efficiency penalty. Number 11. So, which viscosity actually came out on top? No hype, no universal champion, only the right tool for the actual job. In sustained, high-load, high-heat duty, 5W-40 earned its reputation. In the 90% of life that most engines experience, normal, repetitive, non-extreme use, 5W-30 quietly proved superior for overall longevity. It wasn't about being thinner or thicker. It was about delivering steady, dependable protection trip after trip, year after year. Number 12. When 5W-40 is clearly the smarter pick. Let us be crystal clear. 5W-40 is an excellent oil when the mission matches its strengths. Choose it confidently if you regularly pull trailers or carry heavy loads, drive extended high-speed interstate routes, live in very hot climates, operate a turbocharged engine aggressively, consistently see prolonged high oil temperatures. In those worlds, the thicker hot viscosity genuinely buys extra safety margin. Number 13. The most expensive mistake made every day blindly grabbing the toughest-sounding oil for a vehicle that never sees tough conditions. Advice written for high-stress, high-performance, or extreme-duty use gets misapplied to grocery-getter routines that need fast flow, rapid warm-up behavior, and rock-solid consistency during countless partial heat cycles. Number 14. What the factory recommendation really means, but rarely says out loud. Most engines that list 5W-30 can physically tolerate 5W-40 without immediate disaster. The factory choice usually balances emissions, compliance, fuel economy targets, hydraulic actuator performance, and statistical average driving patterns. Longevity often hides in that middle ground between regulations and your personal reality. Smart owners tailor the choice to how the car is truly used, not to what feels safest. Number 15. The brutally honest bottom-line engines rarely die because someone picked outright terrible oil. They die because someone picked oil for the wrong mission, over and over, for 15 years. Thicker isn't automatically safer. Thinner isn't automatically riskier. What separates engines that quietly reach very high mileage is choosing the viscosity that behaves most reliably during the 20,000, 30,000 ordinary hours the engine actually experiences. So the practical takeaway is straightforward. Daily driver, mixed city highway, short trips, average conditions, lean toward 5W-30 for the best balance of protection, stability, and long-term life. Frequent heavy loads, sustained heat, performance driving, 5W-40 becomes the logical choice. Don't chase maximum thickness, chase maximum consistency. Oil isn't magic, it's engineering. Match it to reality. Now I'm curious, what viscosity is currently in your engine? What does your real driving pattern look like? Mostly short hops, long commutes, towing extreme summer heat? Do you pick oil because it sounds stronger? Or because it actually fits how you use the vehicle every single day? Drop your situation below. The costliest error isn't choosing the wrong oil one time. It's choosing the wrong oil thousands of times across the life of the car.